Imagine waking up one morning and learning that astronomers have just dragged entire alien worlds into our solar system. Not asteroids, not comets, full-sized exoplanets, planets from distant star systems, now circling our sun. The night sky would never look the same, and neither would Earth's future. These worlds evolved under completely different stars, with different heat, gravity, and orbital rhythms. So what happens when we suddenly drop them into our calm, carefully balanced solar system? The answer is both spectacular and terrifying. Earth's twin that would burn to death. TRAPPIST-1 is one of the most famous exoplanets ever discovered. It is only slightly smaller than Earth and orbits a tiny, ultra-cool red dwarf star 41 light-years away. Because its star is dim, TRAPPIST-1 must orbit extremely close to stay warm, just 3% of the Earth, sun distance. In its own system, this works beautifully. TRAPPIST-1 sits in the perfect Goldilocks zone, where liquid water could exist. Many scientists consider it one of the best candidates for an Earth-like world. But if we moved it into our solar system, everything would change. Placed near Mercury's orbit, TRAPPIST-1 would suddenly face a star far larger and hotter than anything it evolved for. Even though it would be 13 times farther from the Sun than its original star, the Sun's intense radiation would overwhelm it. Within days, surface temperatures would skyrocket. Within years, any oceans would boil away. Over time, the atmosphere would erode into space. A world once capable of hosting life would be sterilized into a scorched desert. Ironically, this burned-out planet would become visible from Earth as a bright dot in the sky, a glowing tombstone of a world that almost became Earth 2.0. A planet in the asteroid belt. If we tried to be kinder and placed TRAPPIST-1 in the asteroid belt between Mars and Jupiter, the result would be the opposite extreme. Out there, sunlight is weak. TRAPPIST-1 would receive only about 16% of the energy Earth gets. Temperatures would collapse. Oceans would freeze solid. The planet would turn into a global ice ball. But the real danger would not be to the planet. It would be to us. A near-Earth-sized world sitting inside the asteroid belt would gravitationally stir millions of space rocks. Over millions of years, it would fling asteroids toward the inner planets. Earth would face an era of relentless bombardment. Even worse, the planet's gravity could destabilize Mars and eventually influence Jupiter, the anchor of the inner solar system. When Jupiter's orbit shifts, chaos spreads inward. Earth would survive at first. But over deep time, the solar system would slowly unravel, from super-Earth to super-Venus. Kepler 442b's is larger and heavier than Earth, a super-Earth orbiting a cooler orange dwarf star 1,200 light-years away. In its own system, it likely enjoys stable temperatures suitable for liquid water. But around our Sun, that balance breaks. Placed slightly inside Earth's orbit, Kepler 442b would receive far too much heat. Its oceans would evaporate. Water vapor would thicken its atmosphere. Carbon dioxide would accumulate. The planet would undergo a runaway greenhouse effect, the same process that turned Venus into a furnace. But Kepler 442b's stronger gravity would trap even more gas. Instead of becoming a paradise, it would transform into a super-Venus with crushing pressure and surface temperatures capable of melting lead. Worse still, a planet 2.3 times Earth's mass in the inner solar system would disrupt every nearby orbit. Over millions of years, it could destabilize Mercury, Venus, Earth, and Mars, eventually triggering planetary collisions. Earth's climate would grow erratic long before any impact occurred. Seasons would shift wildly. Ice ages and heat spikes would intensify. Civilization might collapse long before the final cosmic crash, the frozen giant that brings asteroid hell. Ogle 2005 Belg 390 LB is a mysterious world discovered through gravitational microlensing. It is at least 5.5 times more massive than Earth and is one of the coldest known exoplanets, with surface temperatures near 223 C. In its distant system, it is a frozen wasteland. Placed into our asteroid belt, it would warm slightly, but not enough to become habitable. Its ice would slowly sublimate, forming a thin atmosphere. But its massive gravity would destroy the asteroid belt. Over millions of years, Ogle would scatter millions of large asteroids inward. Earth would experience an era of frequent mass extinction-level impacts. The sky would burn with incoming fireballs. Eventually, Ogle's influence would destabilize Mars, and then Earth itself. Humanity might survive centuries, maybe even millennia. But planetary roulette would eventually claim us. The ring titan that reshapes the outer solar system. Now zoom out and picture something even more surreal, J1407b. The gas giant famous for its ring system so enormous it makes Saturn look like it's wearing a wedding band. J1407b is often described as Super Saturn, and the headlines are always the same. Massive planet, unbelievably vast rings, and a sky-dominating spectacle if it were anywhere near us. The rings, if the model holds, could extend tens of millions of kilometers, potentially dwarfing anything humans have ever seen in the night sky. In our solar system, the logical parking spot for a planet like this would be somewhere between Saturn and Uranus, a region already filled with icy dynamics, distant moons, and slow orbital rhythms. From Earth, you might not see it like you see the moon, but with a telescope, it would become the most iconic object in the heavens. And if you were standing on a moon of Saturn or drifting in the outer system, those rings would look like a cosmic highway, bright, layered, and impossibly wide, casting shadows across space itself. But beauty doesn't come alone. A planet this massive is not just a visual landmark, it's a gravitational authority. Its presence would tug on Saturn and Uranus like a heavyweight joining a delicate dance. Over time, orbital resonances would shift, moons could migrate into unstable paths, rings could become warped, replenished, or disrupted. The outer solar system, which already moves like slow choreography, would start to feel like a dance floor with a new speaker blasting bass. And then comes the nightmare scenario: Jupiter. Jupiter is the anchor, the gravitational bouncer at the door of the inner solar system. It flings comets, redirects debris, and stabilizes the architecture of the planets. If J1407b's long-term gravitational influence even slightly altered Jupiter's orbit, just a subtle nudge over immense time, the inner solar system could begin to wobble. Not instantly, not dramatically at first, but slowly, like a perfectly balanced spinning top starting to drift. Over hundreds of millions of years, small shifts compound. More debris gets thrown inward. The frequency of asteroid impacts rises. Earth's climate stability could degrade as orbital parameters change, affecting long-term cycles of sunlight and seasons. Even Mercury, already living dangerously close to the Sun, could become more vulnerable to chaotic perturbations. In the worst case, it could be pushed into a destabilized orbit that ends in collision or solar plunge. So J1407b would be the ultimate paradox, the most breathtaking planet you could ever add to our sky, and a silent reshaper that makes the solar system less like a home and more like a long, slow disaster film. Our solar system is fragile. What these scenarios reveal is something profound. Our solar system is not built like a rigid machine. It is more like a delicate mobile, balanced by gravitational tensions perfected over 4.5 billion years. Each planet sits exactly where it does for a reason. Even one misplaced world can unravel everything. Exoplanets are shaped by their home stars. Move them, and they become monsters, freezing, burning, or destabilizing entire planetary systems. Ironically, Earth's safety depends not just on the Sun, but on the precise arrangement of every planet around it. Jupiter shields us from comets. Saturn stabilizes resonances. Even tiny Mercury plays a role in the gravitational web. We live inside a cosmic ecosystem, and it only works because nothing is out of place. The luck of living on Earth. We often look to the stars searching for a second Earth. But this thought experiment shows something even more important. Earth is not just rare because of its size or atmosphere. It is rare because of where it sits. Move planets around, and paradise collapses. Our world exists in a narrow corridor of stability carved by billions of years of gravitational fine-tuning. One wrong planet in the wrong place, and the story of life ends before it truly begins. In the vast violence of the cosmos, Earth is not just special. It is miraculously balanced. If you enjoyed exploring how fragile our solar system really is, there are many more incredible space stories waiting for you. The universe is full of mind-blowing surprises we've only begun to uncover. So for more fascinating science like this, make sure to like and subscribe. It helps the channel and keeps you coming back for more.